All right, we're going to do a couple example problems. Just working through problems so you can come in, take a look, and get some more examples. So the first problem we want to do, we have a, we're going to do finance. Okay, so we've got a savings account that earns, maybe there was an example problem yesterday, 9% interest. That doesn't ever happen. Our savings account earns 0.5% interest a year. And we're going to start with $1,000. Okay, $1,000 to start. This one doesn't work. Good job. All right, we'll go with this one. $1,000 to start. And the savings account, we're going to be lucky if we get 0.5% interest. So we'll go ahead and say we get 0.5% interest per year. No, not 0.5 per year, but 0.5% per year. So we've got to actually convert that into 0.005 when we do the math. But anyway, so we gain 0.5% per year, and we're really ambitious. We think I'm going to be a millionaire. So we want to know, when is my $1,000 investment in a savings account going to turn into $1 million? Okay, so we want to know, when is that going to be $1 million? Okay, so again, we're going to start by writing our equation. Y equals principal times 1 plus the rate to the t. Okay, my y, we're going to put in a million. Okay, so we've got 10 to the 6th. That's a million, right? I don't feel like writing all those zeros. Equals, what's my principal? Is 10 to the 3rd. 10 to the 6th, 10 to the 3rd. Times 1 plus 0.005 to the t. We want to know, when is that going to happen. So let's go ahead and divide off that 10 to the 3rd. Okay, perfect. And then these will cancel and these will simplify. So we get 10 to the 3rd. Notice, yeah, 10 to the 6th divided by 10 to the 3rd. We subtract the exponents. We get 10 to the 3rd equals, so we're going to got 1.005 to the t. And we're going to take the log of both sides. Okay, so we take log of this side, log of that side. So log of this side, we get log of 10 to the 3rd equals log of 1.005 to the t. Okay? Now, log of 10 to the 3rd is just 3. It's log base 10, right? So this side is going to reduce down to 3 equals, and then we're going to use our power rule, pull that t out. We get t times log of 1.005. All right? Like that. And then we are going to go ahead and divide. Divide by log of 1.005. Divide by log of 1.005. And this is going to give us our answer. T equals, let's get down here. T equals 3 over log of 1.005. All right. And just for fun's sake, I'm going to go over here off screen for a second and put that into Desmos. What is 3 divided by log of 1.005? And the answer is 1,385 years. So it'll eventually get there, but I won't be alive to see it. Putting $1,000 in a savings account, it's not going to really grow my wealth very much at all. Now let's suppose instead, got that same $1,000 investment, initial investment, starting off, and we want to still get to $1 million. But this time we're going to put it into, let's say, in the stock market, we're going to put it into the S&P 500 index fund. S&P 500 index fund historically earns about 12% a year. Okay, so gains 12% per year. historically on average over a long period of time. Okay, so 1,000 to start. We want to know when we're going to be a millionaire. So let's again plug in those numbers. We still get 10 to the 6th is equal to 10 to the 3rd, but this time instead of 1 plus 0.005, we're going to do 12%. So that's 1 plus 0.12. Okay? Again to the t. And we do our work. We divide by 10 to the 3rd, divide by 10 to the 3rd. We get 10 to the 3rd is equal to 1.12 to the t. All right? And again, we're going to take the log of both sides. And we get log 10 of 3, that's 3, is equal to t log 1.12. Divide by log 1.12. There we go, these cancel. We get t equals 3 over log 1.12, which is equal to, and again, I'll step off screen and put that on my calculator. $61 years. Okay? Again, that's a long time, but I'll probably live to see that. Well, you will, I might not. The idea here is, what we're looking at, we got the same start and the same end, right? The difference is how much we're gaining per year, right? And we're getting 1,000-fold return here, right? 1,000 times 1,000 what gives us a million, 1,000 times 1,000 what gives us a million. But the difference is how much we're gaining per year. And it leads to a massive difference in the amount of time that we have to wait, okay? And so this is the idea of changing our rate, even, going from 0.5% to 12%, that's a big jump, but it's not, we're not doubling every year, we're not tripling every year, we're still only getting 12%, right? But it dramatically cuts down on the amount of time we have to wait to get there. Okay, so that's an example of how changing the rate will change our answer. Now, let's do another example here. We're going to do 2 more examples. Okay, so for the first example we want to do, we are going to say that we're starting with, we'll go with a population. We've got a population of wolves. We're starting with 60 wolves. 60 wolves. And the wolves gain 5% a year in their population. And we want to know, when is that going to be 80 wolves? Okay, that's a simple enough question. When are we going to hit 80? Okay, so we'll plug this in. 80 is our goal. 60 is our initial. 0.05 t. Right? So this is our initial setup right here. And before we solve it, I'm going to start and go over to a different problem. Let's suppose that we got the same 5% gain. But instead of having 60 wolves, we have 300 wolves. And we want to know, when is that going to reach 400 wolves? Okay, so let's set up this problem. Our target is 400. Our initial is 300. 1.05 to the t. Okay, 5%, that's going to become that 1.05. Okay, now, we've got these 2 problems here. Before we start to solve them, I want you guys to think about, do we think it's going to take longer to go from 60 wolves to 80 wolves? Or do we think it's going to take longer to go from 300 wolves to 400 wolves? All right, just think of that in your head, kind of take an intuitive guess. And then we're going to solve these side by side. All right, so let's start on this side. The first step is going to be divide by 60. We divide by 60. Okay, so this gives us 80 over 60. 80 over 60 is going to reduce down to 4 over 3. We can see that though 80 over 60, that's 8 times 10 over 6 times 10. 10's cancel. That's 8/6, which is, of course, 4/3. Okay, so 80 over 60 is 4/3. Now, so this is simple. Let's finish over here. 4/3 is equal to 1.05 to the t. And then on this side, we're going to start same step. Divide by 300. And that gives us, again, the zeros are going to cancel out. We get 4/3. Okay. So we can see they both reduce to the same problem, right? The 300 wolves to 400 is the exact same calculation as 60 wolves to 80. We only have to gain 20 wolves here. What's happening? We have to gain 100 wolves over here. The trick with this is that percent gains and percent losses don't care about the actual numbers. They only care about the ratio of those numbers. If we notice, every single time we go to solve these, we divide our target number by our initial number, right? Every time we are going to be dividing the target number by the initial number and comparing that to our rate, right? When we get to this step right here, which we always get to, we are comparing the ratio of our target number to our initial number against our rate. Okay, we compare the ratio of our target number to our initial number against our rate. So when we're solving these, the total numbers are unimportant. What's important is the ratio between those numbers. Okay, now let's go ahead and finish solving this. We take the log of both sides. Okay, then we're going to apply the power rule, so that's going to pull that t out. We get log of 4/3 is equal to t times log of 1.05. All right, and we divide off that log of 1.05. Okay, and so that gives us our final answer. T is equal to log of 4/3 divided by log of 1.05. And that's good enough for Desmos. We could apply our change of base rule to say that this is equal to log base 1.05 of 4/3. And we can do more than that, but we don't need to, right? Either of these is fine for putting it into a calculator. And this one would, of course, be the same answer because we have the same equation. Okay, so same equation, we're going to solve for the same thing. So the answer here is log base 1.05 of 4/3 is how long it's going to take us to go from 300 to 400. It's how long it's going to take us to go from 60 to 80. And let's just go ahead and figure out what that number is by using our handy dandy Desmos tool. Here, so we got log of 4/3. And it looks like the answer is 5.89, so we will round that up to 6 years. It's going to take about 6 years to go from here to here. All right, so that's given you 3 good examples of how to solve these problems, as well as maybe some ideas on how to think about these types of problems. That should give you enough that you can complete the homework, but do let me know if you have any questions.